Hi guys, I miss seeing you guys' faces. It's good to be able to provide you some content, however, over video. I hope you guys are all doing well. I hope you had a good spring break. I know things are kind of rough right now, but we got to try to get back to normal here. So, what I'm doing right now is I'm in Photoshop where I can edit these PDFs of our lessons, and I picked a color for us to use for right now. So let's go ahead and get started. So what we're in right now is lesson 11, and it says more about triangles. So your outcomes are going to be that you're going to present informal arguments as to whether or not two triangles are similar. Remember that similar means that if you were to do a series of rigid motions and a dilation, you could make one triangle exactly the same as the other triangle. They're similar. That's what similar means in mathematical terms. In normal terms, we know that similar means it kind of looks like. Maybe not exactly, but it looks like. Students practice finding lengths of corresponding sides of similar triangles. So, some of this stuff you guys have done, you might not recognize it in the way that they're presenting it, or you might. We'll see. So example 1 says that given the information provided is ABC similar, this symbol means similar to DEF. Normally we'd be doing this as a discussion, but I'm just going to go ahead and go through it with you guys. So it says that you're likely to say that you can't tell if the triangles are similar because the only information for one triangle provided, there's only information for one triangle provided. In the previous lesson, you couldn't determine if two triangles were similar because of the AA criterion. Remember, we said that if A and another side are the same angles, your ultimate angles are going to add up to 180. So if you know two sides, you can find out the last side. Okay, so let's go ahead and see what else they say about that. What if we combined our knowledge of dilation and similarity? That is, we know we can translate ABC so that the measure of A is equal in measure to D. As you can see, A equals D. We have A, let me try that again. We have A and D in the same place. So, you can see that A and D are equal, but E and F aren't, right? Well, if you dilated this triangle, then they would be similar. They would be the same. You could dilate this and make it match. We still do not have information about the triangles, but we can use what we know about dilation and FTS to find out if EF is parallel to side BC. So BC, that's these two sides, and EF. So visually, we could probably guess that they are parallel, but maybe we need to check a little closer. We do not have the information we need about the corresponding angles, so let's examine the information we are provided. Compare the given side lengths to see if the ratios of corresponding sides are equal. Is AE over AB equal to AF over AC? That is the same as asking if 1 over 2 is equal to 3 over 6. Since the ratios of corresponding sides are equal, then there exists a dilation from center A. So if you dilated from here, A, With a scale factor of 1/2, that maps ABC to DEF. Since the ratios of corresponding sides are equal, then by FTS, we know side EF is parallel, meaning it goes the same way as BC. Remember, parallel means that lines do not cross and they do not go away from each other. They're running along the same track. No matter how long the line goes, it could go on into infinity. If it is parallel, it will never cross or go away from the other line. It goes along the same line. Like a set of train tracks, each side of the train tracks are parallel as long as the track goes. If they weren't parallel, your train would crash. And the corresponding angles of parallel lines are also equal in measure. This example illustrates another way for us to determine if two triangles are similar. That is, if they have one pair of equal corresponding angles and and the ratio of corresponding sides along each side of the given angle are equal, then the triangles are similar. So if this and this are equal, then this has to be equal, is basically what they're saying. Let's move on. Okay, we're going to ditch that other one here. And I will see you guys in the next video.